American V8s and German turbocharged engines couldn't be more different in their engineering philosophy. The reasons behind these differences will change how you think about engine design forever. Engineering philosophy: power versus precision. American and German engineers approach engine design with completely opposite mindsets, and this fundamental difference shapes every bolt, gasket, and component choice. American manufacturers like Ford, Chevrolet, and Chrysler have always prioritized raw power and mechanical simplicity over efficiency. This philosophy stems from America's unique automotive culture and abundant natural resources that made large displacement engines practical and affordable. According to Consumer Reports data and automotive engineering studies, American engines emphasize torque production at low RPMs, creating that effortless acceleration Americans love. The classic Chevrolet LS series and Ford Coyote V8 represent this philosophy perfectly. Large displacement, naturally aspirated power delivery, and robust construction that any mechanic can service with basic tools. German engineers take the opposite approach, viewing engines as precision instruments that showcase advanced technology. BMW, Mercedes-Benz, and Audi prioritize fuel efficiency, emissions compliance, and technological sophistication over raw displacement. They focus on extracting maximum power from smaller engines while meeting Europe's strict emission standards and high fuel costs. This creates engines that are more complex but offer superior efficiency and performance per liter. Displacement philosophy: big versus small. The most obvious difference between American and German engines is their approach to displacement, and this choice reflects entirely different priorities and constraints. American engines traditionally used large displacements to achieve power goals, typically 5.0 to 7.0 liters, with some performance engines exceeding 8.0 liters. The philosophy was beautifully simple: more displacement equals more power. Large displacement. American engines produce substantial torque from idle, creating that effortless acceleration that doesn't require high RPM operation. This approach suited American driving conditions perfectly: long highways, frequent stop-and-go traffic, and a cultural preference for engines that don't have to work hard to deliver power. Americans had access to cheap gasoline and fewer emissions restrictions, making large displacement engines practical and affordable. German engines typically displaced 1.0 to 3.0 liters, using advanced technology to extract impressive power from smaller packages. A modern German 2.0-liter turbocharged four-cylinder can produce power equivalent to traditional American V8s, while achieving significantly better fuel economy. This approach required sophisticated engineering, but resulted in lighter, more efficient power plants that could meet Europe's strict emission standards and high fuel costs. Turbocharging approaches: conservative versus aggressive. German manufacturers adopted turbocharging early and aggressively, while American companies remained skeptical for decades, creating vastly different approaches to forced induction that persist today. BMW pioneered twin-turbo systems in the 1980s and continues pushing boundaries with technologies like electric turbochargers and variable geometry systems. Mercedes uses sophisticated twin-scroll turbos and complex intercooling systems to maximize power output from small displacement engines. American manufacturers initially resisted turbocharging, preferring naturally aspirated V8s that provided reliable power without complexity. When Americans finally adopted turbocharging in recent years, they focused on replacing larger naturally aspirated engines with smaller turbocharged units while maintaining similar power characteristics. Ford's EcoBoost engines exemplify this approach, providing V8-like torque from turbocharged V6 and four-cylinder engines. According to Consumer Reports reliability data, German turbocharged engines have failure rates 3 times higher than American naturally aspirated engines, but produce 30 to 40% more power from similar displacement. German turbo systems require premium fuel and frequent maintenance to prevent catastrophic failure, while American implementations prioritize durability and serviceability. The difference reflects fundamental priorities. Germans accept reliability risks for performance gains, while Americans prioritize longevity over maximum power output. Fuel system design: simple versus complex. American and German engines evolved different fuel delivery approaches that significantly impact performance characteristics, maintenance requirements, and long-term reliability. American engines traditionally used port fuel injection, where fuel injectors spray gasoline into intake ports before entering combustion chambers. This system provides excellent fuel mixing, reduces carbon buildup on intake valves, and offers simpler maintenance requirements that any mechanic can handle. German engines pioneered direct injection technology, where high-pressure injectors spray fuel directly into combustion chambers at pressures exceeding 2,000 psi, compared to 60 psi for American port injection systems. This allows precise fuel control, enables higher compression ratios, and improves fuel economy while working particularly well with turbocharged engines. According to automotive service data, German direct injection systems require carbon cleaning every 40,000 to 60,000 miles at costs exceeding $600, while American port injection systems rarely need fuel system maintenance beyond filter changes. German high-pressure fuel pumps fail frequently around 100,000 miles, requiring expensive replacements. Modern American engines increasingly adopt direct injection, but often combine it with port injection in dual systems, providing direct injection benefits while maintaining port injection's cleaning action on intake valves. Maintenance philosophy: accessibility versus complexity. American and German engines reflect fundamentally different maintenance philosophies that impact ownership costs, service requirements, and long-term reliability throughout their lifespan. American maintenance philosophy emphasizes simplicity, accessibility, and owner serviceability. Traditional American engines feature easily accessible components, standard fasteners, and maintenance procedures that independent mechanics can perform with basic tools anywhere in the country. American manufacturers historically designed engines for 100,000-mile service intervals on major components, with routine maintenance focused on fluids and wear items. Oil changes, spark plug replacement, and routine service are designed to be straightforward and inexpensive. This approach created engines that owners could maintain affordably throughout their ownership period, contributing to strong resale values and consumer confidence. German maintenance philosophy accepts complexity in exchange for performance and efficiency benefits. European engines often require specialized tools, specific procedures, and manufacturer-trained technicians for proper service. Maintenance intervals may be longer, but individual service events are typically more expensive and comprehensive. German engines frequently feature complex systems like variable valve timing, sophisticated turbocharging, and advanced engine management that require specialized diagnostic equipment and training. Materials and construction: proven versus premium. German engines use premium materials like aluminum blocks, magnesium components, and exotic alloys to reduce weight and improve performance, while American engines rely on proven materials like cast iron and conventional aluminum for maximum durability and serviceability. German manufacturers spare no expense on materials that enhance performance characteristics, with BMW and Mercedes engines featuring lightweight aluminum construction with sophisticated cooling passages and reinforcement structures. These premium materials allow German engines to rev higher and produce more power per liter, but require precise manufacturing tolerances and careful maintenance. The use of exotic materials like magnesium valve, covers, and aluminum silicon alloy blocks demonstrates German commitment to weight reduction and performance optimization, but increases replacement costs when components fail. American engines use heavier but more durable materials that can withstand abuse and neglect. According to automotive engineering studies, German engines typically weigh 20 to 30% less than equivalent American engines, but cost 40 to 50% more to manufacture due to exotic materials and complex construction methods. This weight savings improves handling and fuel economy, but increases replacement costs, reflecting each philosophy's priorities. Electronic integration, simple versus sophisticated. German engines are heavily integrated with complex electronic systems that control every aspect of operation, while American engines use simpler electronics focused on essential functions and reliability. German engine management systems can have over 100 sensors compared to 20 to 30 in American engines, creating vastly different diagnostic and repair experiences. BMW and Mercedes engines feature sophisticated systems that continuously adjust timing, fuel delivery, turbo boost, and valve timing based on dozens of sensor inputs. These systems optimize performance and emissions, but create diagnostic challenges when problems occur. The electronic integration extends to every engine function, from cooling fan operation to oil pump control. American engines use simpler electronic systems that focus on reliability rather than optimization. Ford and General Motors engine computers use fewer sensors and more conservative programming that prioritizes consistent operation over maximum performance. According to automotive repair data, German engine electronics account for 40% of all engine-related problems, while American engine electronics cause less than 15% of issues. German electronic repairs require expensive dealer diagnostic equipment and specialized training, while American systems can be diagnosed with basic scan tools available to any mechanic. Design lifespan expectations, performance versus longevity. German engines are designed for 150,000 to 200,000 miles of enthusiastic driving with proper maintenance, while American engines target 300,000 plus miles of reliable transportation with minimal attention. This fundamental difference shapes every design decision and component choice, creating engines optimized for completely different ownership experiences. German manufacturers design engines for performance-oriented owners who appreciate sophisticated technology and don't mind higher maintenance costs. BMW and Mercedes engines are engineered to deliver maximum performance during their intended lifespan, rather than maximize longevity. This approach creates exciting driving experiences, but requires committed ownership. American manufacturers design engines for mainstream consumers who want reliable transportation without drama. Ford and General Motors engines are over-engineered for their power output to ensure decades of trouble-free operation with basic maintenance. Consumer reports. Long-term reliability studies show American engines routinely exceed 300,000 miles with original major components, while German engines typically need significant repairs or replacement between 150,000 to 200,000 miles. However, German engines provide superior performance and driving excitement during their service life. Manufacturing tolerances, precision versus forgiveness. German engines are built to extremely tight tolerances that optimize performance but require precise maintenance, while American engines use looser tolerances that accommodate wear and neglect without immediate performance loss. German manufacturing precision comes at the cost of maintenance sensitivity, creating engines that reward proper care but punish neglect. BMW and Mercedes engines have tolerances measured in thousandths of an inch, allowing optimal performance but requiring exact oil specifications and frequent changes. These tight tolerances maximize power output and efficiency, but create sensitivity to contamination and wear that demands corresponding precision in maintenance. American engines use more generous tolerances that allow components to wear without immediate performance loss. Ford and General Motors design engines that maintain acceptable performance even when maintenance is deferred or incorrect fluids are used. Engineering studies show German engines lose performance rapidly when maintenance is neglected, while American engines maintain consistent operation despite abuse. German engines require premium oils and exact specifications, while American engines tolerate conventional oils and longer change intervals. The differences between American and German engines reflect decades of distinct engineering philosophies, regulatory environments, and cultural preferences that created fundamentally different approaches to automotive power. Americans prioritize displacement, simplicity, and reliability, while Germans focused on efficiency, technology, and performance optimization. These approaches created engines with completely different characteristics that continue influencing modern development. Today's convergence combines the best of both worlds, offering consumers engines that provide German efficiency with American reliability. Understanding these differences helps you appreciate why your engine behaves the way it does and what to expect from different automotive cultures. Neither approach is inherently better. They serve different purposes and appeal to different types of drivers with varying priorities and expectations. If you enjoyed this video, hit that like button, and if you like content like this, hit that subscribe button, and I will see you in the next one.